Hello, good evening everyone. Hello, good evening everyone. Welcome to Unacademy, India's largest online learning platform, which is acting like a bridge between the dreams and success of many students in India. Right? Not only just GATE students, other students also are getting benefited out of this Unacademy. Right? So, good evening. So, just wait for a few more students to join, 1 or 2 minutes. And today we are going to discuss about semiconductor physics part 8. Semiconductor physics part 8. So meanwhile, for those who are coming for the first time, let me introduce myself. So myself Shravan Kumar. Having 10 plus years of teaching experience. So I have master's degree. From JNTU Hyderabad in VLSI systems design. And I have mentored more than 10K students for GATE and ESE. And the subjects which I teach is EDC, that is electron devices and circuits, which we are discussing right now. And we'll also discuss analog electronics. Good evening, Sri Charan. Analog electronics, and then we'll have digital electronics, and then EMFT. As I told you, so EDC in EDC, we may get 10 marks minimum, and analog is also around 9 to 10. 9 to 10. 9 to 10 marks will get. 10 marks will get, and digital is definitely will get 9 marks, and EMFT is also 9 to 10. Just follow me to score 40 marks. So I'll try to cover 40 marks. Okay, out of 60, the technical round, but out of 70, I have 40 marks I'm going to cover. You need not worry. Okay. So the promo code uh, of me is SVS10. The promo code is SVS10. That is, we will get 10% off on plus subscription. We'll get 10% off on plus subscription. Okay. So, so what is the use of having plus subscription? The use of having plus subscription is you will attend live sessions, and you'll have a crash courses, quick courses available. This is important, sir. For me, this is important. That is a weekly test. Every week you will have test. Every week you will have a test. This is very much important for a GATE student. Not just theory part. Practice is important. Understanding the concepts is also very important. And solving many problems. Maybe theory or problematic, they are important. So for a plus student, will have the benefit of writing weekly tests, and this is also important. You will have a doubt solving session. For every 4th hour, you will have a doubt solving session. And we have something called English and Hindi batches are available. So if you are South Indian, better to go for English, and if you are North Indian, you are better to go for Hindi. And we have something called RIB, rank improvement, batch. This rank improvement batch is for those who are having already cleared the GATE examination, and looking to improve their rank. Looking to improve their rank. So this is also very important. Now there is something called iconic. So iconic, along with this plus benefits, iconic will have a personal coach. You will be assigned to a personal coach, right? And they will give you a study planner, customized study plan for you, for your performance, for individual performance. You will have a customized study plan. This is very much important, right? Preparatory study material, specialized notes and practice sets. This is also important. As I told you, as the exam is coming closer, so you need to have these notes. You need to have short notes. We call generally anything short notes, whatever. That is very important, right? So, and you have something called study booster sessions. So, receive essential guidelines via regular workshops. So, study booster, how to improve your studies, to get the rank, to get the best rank, Okay. Next, personalized test analysis. So you'll have a personalized in-depth analysis for each and every section of your test. You will be available. In-depth analysis will be, we are doing in-depth analysis. Okay, in-depth analysis we to do. Okay. Now these are the fee structures, which are changed fee structures. As I told you, for 12 months course, you have 27,225 rupees. So 20,000 to 25 rupees. So if you apply my code SVS10, you get 10% discount. 10% discount. Just calculate whatever it may be. So you can have a EMI facility for 6 months and whatever it may be. And you have for 18 months also. So this is specially for those who are preparing for 2022. This is for 2022. Why? Because 18 months time. So if you take right now, it will be around 14 months. So, but because of that, they are offering 18 months course. They are offering 18 months. So if you are offering 18 months, what happens is you can save 61%, and the fees will be 34,650. And again, if you use this referral code SVS10, you use referral code SVS10, you will get 10% off. 10% off. Right? So get another plus. This is for 24 months. Those who are in third year, I would recommend you to go for this 24 months subscription. 24 months subscription, which may also be, sir, it is not just for GATE, sir. It is not just for GATE. You can prepare for ESE. You can prepare for ESE, DRDO, ISRO. Many exams will be coming. So better you go for 24 months, those who are in third year, right? So use my subscription code SBS10, 39,600, and just go for proceed to payment, so that you'll get 10% discount, right? So this is for plus. So if as I told you, for iconic, it's a 12 months course. For 12 months course, you are going to have 45,225 rupees. And again, of course, as I told you, you'll get 10% discount. This is 4,500. So around 40,000 you'll get. You are going to get 40,000. You're going to get 40,000. Okay. You're going to get 40,000. And for 24 months iconic, fees will be 67,600. This is cheaper, sir. This is cheaper for 24 months. Whereas if you go for a offline for 1 year, they will be charging 66,000, 60 to 70,000, and you will not have any repetition, sir. So if you have a 24 month subscription, what you can listen to the classes at any time, any number of times you can listen. You can interact with the faculty many times. You'll have a personalized guide will be there, coach will be there until you get succeed in life. Preetham, good evening. Good evening, Preetham. Okay. So this is again 24 months subscription. So you'll have a 10% discount again on this. So around 60,000. So 24 months, 60,000 means around 2,500 per month. You're going to get 2,500 per month. Okay. After description, after this, right? Okay. So I would recommend any one of you to go for this. So you can follow me on Unacademy. So you can use this, you can store this. Now user Z614A9 LLPDQQ. This is my user ID. This is my user ID. This is my user ID. So you can use this. You can use this. Okay. So now, so before going to discuss about what we have discussed, let's go back and discuss what we have discussed in the previous class. So let's discuss what we have discussed in the previous class. We started our discussion with some problem. So this was the previous 2017 question itself, but for 2 marks we got. And and another problem we also discussed. 3 problems, 4 problems, 5 problems, 6 problems. Achha, last class was problems. Achha, okay. Entire around 10 problems we have discussed, I think. So all our problems we discussed. All our problems only. So as I told you, in the next class I am going to discuss drift and diffusion currents in a semiconductor material. So now we will start discussion about our today's topic. Drift current. So by definition, what is drift current? Drift current. The current, I'll just try to write down here so that you can see the current. The current which flows. The current which flows when an external voltage, or you can write from battery, external voltage is connected is called drift current. What do you mean by this? Right? Drift current will not be internal. Drift current will be due to the application of external. When you apply some external voltage, the current which is generated in a semiconductor is called a drift current. Okay. So what is that, sir? External voltage means it is electric field. That is electric field. So we know that J. What is J? What is J? What is J? What is J, sir? Are you able to see my screen very properly or not? Are you able to see my screen properly or not? Hello? Is my screen visible properly? Okay. Okay, Sricharan. Okay. So what is J then? J is current density. The current density J is directly proportional to the applied electric field. So what we can write is J is equal to sigma E. J is equal to sigma E. Right? So for N type, for n type, J is equal to N Q mu N into E. So what is J? J is nothing but I by A. Yes or no? I by A is equal to NQ mu N into E. So from this what we can write is I, that is drift current I, is equal to N Q mu N E into A. I can write here because it may not be visible for you. So A into this is for what, sir? N-type material. This is for what? N-type material. So for P-type, again J is equal to P into, can you write directly? Can write directly? P, Q, mu P into E. Mu P into E. Again this is going to be I by A. Sir, for your convenience, I am writing again and again. Don't think that I am repeating the concept. Right? This is I is equal to P, Q, mu P into E. A is the area of cross section. Sricharan, A is the area of cross section. Area of cross section. Charge density we have discussed, right? Density. Understood? Okay. So this is going to be, current for P type. Drift current. This is drift current I can call. Drift current. So if for what it will be for intrinsic semiconductor? For an intrinsic semiconductor, for an intrinsic semiconductor, what we know, sir, J is going to be sigma I into E. Sigma I into E, that is equal to, can I write this directly? Ni into mu N plus mu P into Q into E. This can be I by A. So I is equal to A into Ni into mu N plus mu P into Q, right? So for intrinsic semiconductor, both charges will be available, sir. Both charge carriers will be available. That is why we got mu N plus mu P. We got mu N plus mu P. We got both mu N plus mu P. This is for intrinsic semiconductor. If you want to write, you can write II also. If you want to write, you can write II. It is intrinsic semiconductor drift current. Intrinsic semiconductor drift current. Intrinsic semiconductor drift current II is equal to A into Ni. Ni is intrinsic concentration. Ni is intrinsic concentration. Mu N is the mobility of an electron. Mu P is the mobility of a hole. And Q is the charge of electron, and E is a applied electric field. Applied electric field. Okay. Now, so now diffusion current. So the name itself indicates something different, sir. It is diffusion current. diffusion current. So now consider some here some area. Let me draw something. So here let's think that this is a consider for a n-type material. Consider n-type or p-type material. Let's consider p-type material. Let's assume that it's going to be p naught. This is at x is equal to 0, and at some point x, at some point x, at some point x, assume this point is at x, at some point x. Now, in a semiconductor, sir, listen to. It means spread out, diffusion. Yeah. Okay, correct. Okay, Sricharan. Okay. Now see here, at x is equal to 0, the concentration of holes, because as we are considering this is a p-type material, as we are considering this as a p-type material, the concentration is high. The concentration is high at x is equal to 0. As you are moving away from the x, now what's happening, sir? The number of holes is decreased. That means concentration is decreasing. Concentration is decreasing. Now we all know that the charge carriers will move from high region to low region, right? High concentration. This is high concentration region. This is high concentration region. What is this, sir? High concentration region. High concentration. Now here what we have? We have this is a low concentration. Low concentration. That is low concentration. That is low concentration. Now what happens? See here. We know that what happens, sir? Always the charge carriers, maybe electrons or holes, will try to move away from high concentration region to low concentration region. High concentration region to low concentration region. So now what happens, sir? These holes will move in this direction. These holes will move in this direction. These holes will move in this direction. So that is when you are moving away from the junction, when we are moving away from x is equal to 0 to some place x, the concentration is decreasing. The concentration is decreasing, right? So you are moving in the positive direction. You are moving in the positive direction of the x, right? So now this is called concentration gradient. Concentration gradient. So dp by dx. So what do you mean by dp by dx? Concentration gradient. What do you mean by this? The difference of change in the holes with respect to change in the distance, right? Change in the holes with respect to change in the distance. So here the holes concentration is very high. Here the holes concentration is very less. So as you increase positively, the holes concentration is decreasing. Now, when holes are moving from high concentration region to low concentration region, what happens, sir? There exists a current. When holes are moving, yes or no? When holes are moving, when holes are moving, now what happens, sir? Current exists. Current exists. Sir, did we apply any voltage? No external voltage. No external voltage. No external voltage. No external voltage. But still, the charge carriers are moving from one region to other region, one region to other region. So because of that, there exists a current I. There exists a current I. And it is because of the concentration gradient. It is because of the concentration gradient. So now the current density Jp is directly proportional to the concentration gradient. Concentration gradient, that is dp by dx. Concentration gradient. Yes, this is complete EDC in English. Guru Balaji, this is going to be completely in English. What are you expecting? Okay. So the Jp is directly proportional to minus of, so dp by dx. So why it is, this is minus? Why minus? Minus sign indicates, minus sign indicates dp by dx is decreasing. Okay, so minus indicates it is dp by dx. So what we can say is, we have a constant, that is jp is equal to minus q dp into dp by dx. So this is very important formula. This is very important formula. This is very important formula. What is this formula, sir? What this formula indicates? This formula indicates current density. Current density. Diffusion current density. Diffusion current density. Diffusion current density. Diffusion current density in a p-type semiconductor. Yes, we will have everyday live classes, Guru Balaji. Every day we will have live classes. Every day we will have live classes. So in a p-type semiconductor, so Jp is equal to minus q into dp by dx. dp by dx. So what is dp here? dp indicates diffusion constant. Diffusion constant. What are the units of this? It's going to be meter square per second. So for holes, dp indicates diffusion constant. Okay. Now similarly, for a n type, for a n type material, for an n type semiconductor, can somebody tell me what is Jn? We can call that Jn. That is current density Jn is equal to Q dn by dx. dn by dx. This is another formula. Sir, many questions are asked based on these formulas in the previous gate examination. So be careful, be careful, be careful. So I would request you to sometimes practice these formulas and first actually understand the formula. What is understanding formula, sir? So if you go and see what I told is this simply, this is the concentration gradient. This is the concentration. You need not by heart. You need not by heart the formula if you remember. If you remember the concept. What is the concept, sir? The current density is directly proportional to the concentration gradient. Concentration gradient. What do you mean by concentration gradient? A high concentration is available at x is equal to 0 and here it has lower concentration. It has low concentration. So when these charge carriers are moving, when these charge carriers are moving from high concentration region to low concentration region, definitely there exists something called current. Without applying any external voltage, you will get a current, right? So this is because of holes present in a semiconductor material, right? So what is this? This is because of the electrons present in a semiconductor material. Electron present in a semiconductor material. This is very important. Next. So what do you mean by total current density? Total current density. So current density is because of current is because of current. We have two currents. What are the currents, sir? Just now we have studied. One is drift current, and then diffusion current will also exist. Diffusion current. So current is because of both drift plus diffusion. Current is because of both drift plus diffusion. So now for N type, the total current density, I need not write here again. Oh. So for an N type, so this current density Jn, shall I write Jn is equal to Jn drift plus Jn diffusion. Jn drift plus Jn diffusion. So what is Jn drift? Go back and see what we have discussed. So this is what we're discussing for N type. We're discussing for N type. So we know that this is going to be NQ mu n into E. Simply write it here. So Jn is equal to N Q mu n into E plus Jn diffusion. So what is that? The previous slide we have written here. So Q dn by dx. Q dn by dx. Q dn by dx. This is going to be Jn. Sir, as I told you many times, many problems are asked in the previous gate examinations. Many problems are asked in the previous gate examination based on these formulas. So be careful while you are listening and understand. As I told you, you need not by heart anything. Just understand the formula. So what are the units for current density? Sir? Going to be I by A, amperes per meter square. amperes per meter square. Jn is going to be amperes per meter square. This is for N type. And what would be for P type? What would be for P type? Total current for P type, I'll write it with a, so for P type, that is Jp. Again, this is Jp is equal to Jp drift plus Jp diffusion. So what is Jp drift current? Very simple. It's very simple. P, Q, its corresponding mobility mu P, and its applied electric field E, minus Q dP is going to be dP by dx. Is going to be Jp. Jp. Sir, you may get a doubt. Why there is no minus sign in Jn? Why there is no minus sign in Jn? Even if you don't get, I'll generate the doubt, sir. Huh? So can somebody tell me why we don't have minus? Why we have minus for only this? Only this for P. Only this for P. Only this for P. Why we have? Because, sir, let me repeat again. Let me go back and see. See now here what's happening, sir. So this is as you are moving away from x is equal to 0. So this concentration is decreasing. This concentration is decreasing, and current Jn is in this direction. Jp is in this direction. But if it is in case of so Jp is as concentration gradient is negative. This concentration gradient is negative. Concentration is gradient. If it is electron. So now what happens, sir? For an electron, for an n-type, I will write here so that you will not forget. For n-type, we are going to have Jn Q dn minus of, actually minus q you can write. So this is going to be minus of minus dn by dx. dn by dx. Or you can write one more thing. Or you can write directly. This is going to be minus jn is equal to q dn minus dn by dx. So because of that, we'll get what we'll get, sir? Jn is q dn dp by dx. What you get? dp by dx. What you get? dp by dx. What you get? Clear? Is that clear? So total current density is going to be for n type. This is total current density, and this is going to be for p type. For p type. Now next. Moving on to something very important, sir. Very important, because many times, many questions are asked on this topic called Einstein relationship. Einstein relationship. So what do you mean by Einstein relationship? What do you mean by Einstein relationship? Directly I write the statement. I mean the equation I'll directly write Einstein relationship. I'll directly write the Einstein relationship. The C is going to be dP by mu P is equal to dn by mu n is equal to, he said, constant, that is equal to, we can call it as Vt. It's going to be Vt. Most important formula for problem solving. This is Einstein relationship for electronics. Einstein relationship for electronics. Einstein relationship for electronics. Very important. So what is this dp, sir? dp is diffusion constant. dp and dn are diffusion constants. Diffusion constants. Whereas mu p and mu n are mobilities. Mobilities. And what is the Vt? What is Vt? What is Vt? Vt is equal to Kt by Q. This is very important. This also very important, sir. This Vt plays a major role many times. We call this as volt equivalent temperature. Volt equivalent temp. Correct, Sricharan. We call it as volt equivalent temperature. Volt equivalent temperature. Volt equivalent temperature. Vt is equal to Kt by Q. That is volt equivalent temperature. Volt equivalent temperature. Where K is what, sir? K is Boltzmann's constant. Where K is Boltzmann's constants. Boltzmann constant. Boltzmann constant. Q is charge of an electron. Charge of electron. The T is temperature in degrees Kelvin. Temperature in degrees Kelvin. Temperature in degrees Kelvin. This is very, very important, sir. Now, but at room temperature, Vt can also be written as T by 11,600. This is also important formula, you should remember. This is also important. Vt is going to be, Vt changes with respect to temperature. Temperature equivalent volt. Volt equivalent temperature. This can be called as volt equivalent temperature. So at T is equal to 300. At T is equal to 300. So what is Vt, sir? Vt is approximately equal to 26 millivolts, or it is actually equivalent to 0.259 volts. Zero point 0.0259, right? 260 millivolts we call it as 2.6 millivolts. So 0.0, sorry, this is going to be 26 millivolts. 0.0259, 0.0259 volts, 0.0259 volts, 0.0259 volts. This is also very important. Very important. Okay, next. So here comes a very important electrical properties of silicon and germanium. So for that, let me try to draw a table so that you will have a These properties are very important, sir. Here you can write property. Here you can write proper. Here you can write property for germanium and then for silicon. For germanium and silicon. So what is atomic number of this? Can somebody tell me what is the atomic number of atomic number? Atomic number. What is the atomic number of germanium? Silicon or germanium, can you tell me? Atomic number of germanium is going to be 32. Atomic number of germanium is going to be 32. Whereas atomic number of silicon is going to be 12. Sorry, 14. Is going to be 14. Atomic number of silicon is going to be 14. Atomic number of silicon is going to be 14. Okay. Next. Next. Atomic weight. Next, atomic weight. Atomic weight. Atomic weight of germanium is going to be 72.6, whereas the atomic weight of the silicon is going to be 28.1. 28.1. So next is going to be something which we have no, sir. Atoms per centimeter cube. Atoms per centimeter cube. Atoms per centimeter cube is going to be 4.4 into 10 to the power of 22 for germanium. This is going to be 5.0 into 10 to the power of 22. 5.0 into 10 to the power of 22 is atoms per centimeter cube. Atoms per centimeter cube. Right? And then, so what we have to, sir? So EG naught. EG naught. What is EG naught? EG naught. At T is equal to 0 degrees Kelvin, at T is equal to 300 degrees Kelvin. For silicon, it is going to be 0.785. It is going to be 1.21 in electron volts. EG naught is going to be in electron volts. In electron volts. It is going to be at 300 degrees Kelvin. This we have already discussed. We have already discussed about this earlier. Yes or no? Yes or no? We have already discussed about this, sir. We have done some problems also. We have clearly discussed why this EG naught will come. We have clearly discussed why this EG naught will come. Yes or no? So EG naught at T is equal to 0. At T is equal to 0 what? And at T is equal to this thing what? We have discussed. Then intrinsic concentration. Intrinsic concentration. What is intrinsic concentration? Ni. Ni. Intrinsic concentration. So what was the intrinsic concentration for germanium, sir? It is 2.5 into 10 to the power of 13 atoms per centimeter cube. This is going to be what? 1.5 into 10 to the power of 10. This also we have discussed very clearly. So I'm just trying to summarize now actually. It's going to be summary. It's going to be summary kind of thing. Next, what we are going to have is let's consider something called mu n. What is a mu n? Electron mobility. Electron mobility is going to be 3800, and it is for mu n for silicon is going to be 1300. Mu n for silicon is going to be 1300. Very simple. Then what is going to be mu p? Mu p. Sir, what are units for this? Centimeter square per volt second. Correct. Centimeter square per volt second. This is also centimeter square per volt second. So mu p is going to be 1800. And what about this? It's very low, sir. This is going to be 500 only. So 500 only. So remaining properties we'll discuss in the next slide because it may not be visible for you. So we have two more properties to discuss. Very simple properties. So these are the properties which we have discussed in the previous class only. So the remaining two properties are going to be. So what are the remaining properties, sir? dn and dp. dn and dp. What is dn? What is dn? You forgot. dn and dp. Did you forgot? Go back and see if you forgot. So dn and dp indicates diffusion constant of hole and electron. Diffusion constant. So the diffusion constant dn and dp for germanium and for silicon. Germanium for silicon. And the dn is going to be 99 and for silicon is going to be 34. Silicon is going to be 34. dp is 47. Diffusion constant 47. And then this is going to be 13. So as it is may not be visible, it's going to be for silicon and germanium. Let me write here. Let me rub here. So it is as I know you are not visible. This is not visible. So I'll write here. This is for germanium. This is for silicon. These are the electrical properties. Here are the electrical properties of germanium and silicon. Germanium and silicon. Very important. Okay. So we'll stop it here now. Now we will from tomorrow we'll discuss about. So we'll try to see what is there in tomorrow's session. In tomorrow's session we'll discuss some problems regarding this. We have a few problems that we will discuss in tomorrow's session. Clear? So there is a small change in the channel. So earlier we used to be on Creatrix Telegram. This is a new Telegram channel. Where you can find my all notes. https://ht.me/Unacademy GATE Telugu. So this is a channel name. Don't think that I'm going to teach in Telugu. This is just a channel name. Unacademy GATE Telugu channel name. Channel name is Unacademy GATE Telugu. The telegram is going to be Unacademy GATE Telugu. Please do join. Please do join for to get the notes which we have discussed right now. The notes which we have discussed right now. This is a new channel. So don't all videos will be migrated from the previous channel 101. Earlier I used to teach on electrical and electronics 101. All those videos will be migrated to this. All those videos will be migrated to this. You need not worry. They will be soon. They will be appearing in this Unacademy GATE Telugu. So this will be again changed to Unacademy GATE English. Soon this will be changed to Unacademy GATE English also. Right? You need not worry. You need not worry. Right? And then, so we have many channels. We have many other channels also. We have channel for Creatrix GATE for EEE, ECE, and instrumentation, electrical and electronics, electronics and communication, instrumentation, mechanical engineering, and production engineering. And then we have engineering sciences. This XE stands for engineering sciences. And we have a separate channel for GATE civil engineering, Unacademy GATE civil engineering. And we have something called engineering Pathshala. From basics we will discuss about this engineering Pathshala. So in Unacademy computer science for those computer science engineering students, this is very good, sir. Very good. And Unacademy GATE questions. This is for those actually who are interested only to solve problems, right? Many questions are available. Thousands of questions are available on this YouTube channel. So many students are registering here. So I would request you to register for all these channels. And this is the channel which we are discussing right now. That is Unacademy GATE Telugu. And soon it will be going to be changed. You need not worry. Unacademy GATE English. And we have something called electrical junction. If you have any queries, please post me the queries. So otherwise, so we will just summarize what we have discussed so far. We started our discussion with the drift current. What drift current, sir? The current which existing due to the external voltage, external voltage, and that current J is equal to NQ mu n into E. NQ mu n into for N type. For P type it is going to be NQ PQ mu P E, and for intrinsic semiconductor, the drift current I is equal to A into Ni, where Ni is intrinsic concentration, and mu n plus mu p. Mu n is mobility of electron, mu p is mobility of holes, and Q and E are what we already know. I need not tell you again. So diffusion currents, we have discussed the concept of diffusion current, which is existing due to the concentration gradient, that is dP by dx, minus dP by dx. So we call this as the dP by dx concentration gradient. That is there is a difference in the states, right? The difference in the concentrations, that is called dP by dx for P type material. And this exists. This Jp is equal to minus Q into dP by dx, minus Q into dP by dx, and Jn is going to be Q dn by dx. By dx. This is also very important. And we have also seen the total current density. Jn is equal to drift current density plus diffusion current density. That Jn is equal to NQ mu n into E plus Q. Diffusion current Q dn by dx, amperes per meter square. Here also it is amperes per meter square only. This is also amperes per meter square. And which is having minus sign. The minus sign indicates that the concentration gradient is decreasing. Now we have seen the Einstein relationship. This is very much important. That is dP by mu p is equal to dn by mu n is equal to constant. Vt is equal to Vt. What is Vt? Volt equivalent temperature. volt equivalent temperature. This is also very important. The value of the constant value of the volt equivalent temperature is going to be 26 millivolts and 0.0259 volts at 300 degrees Kelvin. And we have seen the different electrical properties of a silicon and germanium. We have seen different electrical properties of silicon and germanium. So we will discuss the remaining in the next class. Thank you. Thank you.